All right, let's dive into something truly mind-bending today. We're going to explore a wild idea that connects our messy, everyday thoughts to the fundamental structure of the universe. It asks this incredible question: what if we don't just live in the universe? What if we're actively helping to build it? So, the central idea here is that reality isn't some pre recorded movie we're all just watching. Nope. It's more like a play, and the script doesn't even start until an observer, until you, walks onto the stage. This model suggests the universe actually needs us to snap into focus. But that brings up a really fascinating, kind of funny problem. If observation is the key to everything, what happens when the observer isn't some perfect focused scientist, but, well, just a regular person? Someone who is a little stressed, a little in love, or honestly just wondering what to eat for lunch. To even begin to unpack that, we have to become detectives. We have to look into a 100-year-old mystery that's been bugging physicists for generations: the quantum measurement problem. I'm sure we've all heard of Schrodinger's cat, right? At the quantum level, particles can exist in a weird smear of possibilities, a state called superposition. So if you link a cat's fate to one of these particles, the cat itself becomes a quantum smear. It's bizarrely both alive and dead at the exact same time. The real puzzle, the core of the mystery, is: why does the simple act of peeking in the box force reality to pick one? Now, the main tool physicists have for navigating this quantum weirdness is the legendary Schrödinger equation. But here's the thing: this brilliant piece of math goes completely quiet right at the most important moment. Okay, don't let all the symbols scare you. The idea behind it is actually pretty simple. The part on the left is just a fancy way of describing how something changes from one moment to the next. And the part on the right, that's just its total energy. So it's basically a perfect recipe for predicting how a quantum system is going to behave over time. Well, almost perfect. And here's the giant catch. That perfect rulebook tells you everything about what happens before you look. But at the exact moment of measurement, the moment that blurry superposition collapses into the one single reality we actually see, the equation just goes silent. It offers zero explanation for how that choice gets made. The mystery gets so much stranger when we try to zoom out, when we apply these same quantum rules not just to a single particle, but to everything, the whole universe. This slide shows it all. Look at the equation on the left for a normal particle. You see that little letter T in there? That stands for time. It's ticking along. Things are happening. Now look at the equation on the right. That one describes the entire universe. And the T is gone. It just vanishes from the math. From this cosmic perspective, the universe is a static, frozen block of reality. So wait a minute. If the math for the whole universe says it's frozen in time, then where does the flow of reality we all experience come from? The equations give us nothing. And this is where a radical new suspect enters our detective story: the messy, biased, complicated human mind. You see, physics has always treated the observer like a neutral robot, a perfect, emotionless instrument. But what if that's the big mistake we've been making all along? What if all our internal mental noise, our hopes, our anxieties, our daydreams, isn't a flaw? What if it's a key part of the process that actually helps shape the outcome? So how could that possibly work? Well, this model tries to put some actual numbers on our messy minds. It's a weighted consciousness model, and it breaks down into 4 simple steps. First, you break consciousness down into different intentions, like love for the cat or just plain indifference. Second, you give a weight to each one based on how much mental focus it's getting. Third, you assign a bias. What outcome does this intention want? And finally, you crunch all those numbers to get the observer's total overall bias at that one moment. And here's where it gets really, really cool. This isn't just philosophy. The model makes a concrete, testable prediction. Your thoughts can actually change the quantum odds. Let's take an observer who just really, really wants that cat to be okay. Their mind is totally flooded with love for the cat. According to this model, that powerful emotion isn't just a feeling. It actively nudges probability. So instead of a clean 50-50, the chance of the cat being alive jumps to 58%. But what about our more realistic observer? The one who's thinking about the cat, yeah, but also about lunch and about that argument from this morning. Their mind is all over the place. The model shows their bias is weaker, of course, but it's still there. It still shifts the odds, nudging them to 53% in favor of the cat being alive. And this table really shows the whole shebang. A perfectly neutral robotic observer, They get the 50-50 odds that standard physics predicts. But the moment a real human mind gets involved, the probabilities start to shift. A little distracted, strongly loving, even secretly hoping for the worst. It creates this whole spectrum of possible outcomes. The observer's mind literally becomes part of the equation. So this all leads us to a final, pretty profound thought. What if we've been looking at our own messy human minds in completely the wrong way? What if all that internal chatter, all those conflicting feelings and distractions, what if that isn't a flaw in our ability to see the universe clearly? What if it's actually the incredibly complex result coming from a staggeringly powerful computational engine? This model argues that our brains are quantum computers, just not for doing physics. They were optimized over millions of years for something much, much harder: social survival. I mean, think about it. You walk into a room and your brain instantly runs trillions of calculations on social status, on intent, on threats, all just so you can fit in. That kind of social computation is way beyond what even our best quantum computers can do today. And that leaves us with this incredible paradox. Our brains are pretty terrible at calculating something like planetary orbits. So, in that sense, we're very inefficient quantum computers. But at the same time, we might just be the most powerful devices in the cosmos for observing and collapsing the quantum possibilities of reality. We are inefficient, yes, but we are the richest observers. And that really makes you wonder, doesn't it? With every thought, every intention you have, what reality are you helping to create right now?